Helm is awesome. I mean, I will skip the discussion whether Helm is better or worse than customized, but for the moment, let's assume that you're using Helm, and I'm assuming that you're using Kubernetes. I mean, if you're not using Kubernetes, then go back to 20th century, right? Anyways, you're using Helm, that's my assumption, and if you are, then you're probably experiencing pain of how to release your applications packaged as Helm charts at scale. When you have one or two applications or three, and then you maybe have two environments, working with Helm is relatively straightforward and easy. You create a Helm chart, you modify values depending on the environment where you're running, you're updating those values every time you make a new release, and it's all good, it's amazing. But what happens when you have more applications? Let's say 10, 100, 1,000 applications. And on top of that, we need to multiply it with the number of environments. We might have staging, integration, production, this and that. A few environments, 3, 4, 5, 6, maybe 10, and then multiply with the number of applications. And the situation gets complicated because Helm is not designed to manage our applications at scale. Instead, it is designed to package a single application with its dependencies and create some variations of that application depending on the environment we are running in. Now we can create chart of charts. Did I just invent that term? I'm not sure whether anybody calls it chart of charts. Anyways, you can create a chart that will contain all the applications running in an environment as dependencies of that chart, but then the situation becomes hard to maintain, let's say, or not really user-friendly, or not really what Helm is supposed to be about. So we are using Helm and we have trouble how to create releases of our Helm applications and how to do that at scale. And that is where Helmfile jumps in. Helmfile tries to solve problems of running at scale applications packaged as Helm charts. So what is Helmfile? If I go to the website, I will see highlights of a couple of points, and they are, let me read it, a way to keep a directory of chart value files and maintain changes in version control, apply CI/CD to configuration changes, and periodically sync to avoid skew? I'm not sure what's the word in environments. Anyway, drift in environments. That is somehow true, but I think that it's missing the point. The real advantage of Helmfile, at least from my perspective, is the ability to define whole environment, let's say production, in one place, as different Helm charts with different values and different tags and images and properties and what's not, right? It is a way to define what is running in an environment and have a relatively straightforward how to update that definition with each new release we are creating. So it is a mechanism to define releases and to run Helm charts at scale. It is like, okay, here's the definition. It is Helm on steroids. That's what it is, really. So let's explore Helmfile in 20 minutes or less and see whether it makes sense for us to use it. Here's TLDR. It does make sense to use it if you're not using some other tools. That's confusing. Let's go to the live session, hands-on, and see what is it all about. Let's talk about setup. What did I do in advance before I started recording this session? Not much. Actually, a few things. I cloned the repository that contains sample manifests. I created a cluster. You can use any Kubernetes cluster, but today I'm using K3D, which, if you're not familiar with, I explored in one of the previous videos, and the link to the video is up there above my head somewhere. It's also in the gist. Now that I mentioned the gist, there is a gist. It's in the description of this video, so go there, check it out. You will find all the commands that you will need if you want to follow along what I'm doing. I installed Helm. I'm assuming that if you're watching this video, you already have Helm. Probably you wouldn't be interested how to run Helm at scale if you don't have Helm, right? I installed Helmfile and I installed a couple of Helm plugins. Helmfile depends on some Helm plugins. It is sometimes painful to figure out which plugins are needed, but hey, documentation can always be improved. Now let's go and explore Helmfile and see what do we get with it. What is that thingy? I will start with the simple definition, potentially the simplest possible. Helmfile maybe not the simplest, but very simple one. And then we're going to progress towards more complex use cases. So here it is, Helmfile Prometheus, right? Let's say that we want to run Prometheus in our cluster and we would like to define it using Helmfile. And this is the definition. So over here we have repositories and releases. And even though this looks extremely simple, and it is, it already shows a couple of pain points of Helm, right? We need to manage repositories manually, you know, Helm repo add, Helm repo update, instead of specifying those repositories somewhere, and Helmfile helps us with that. Instead of thinking, oh, what is the repository that contains the chart I want to install, we can just specify it in a file and say, hey, Prometheus is in this address. It's similar with releases. We cannot specify the namespace, at least not easily in Helm. We need to specify -- namespace and -- create namespace. Helmfile will do that for us. It allows us to specify the namespace, the chart that should be deployed, and the name that is whichever name you want, right? And this chart here, Prometheus, is actually a reference to the repository Prometheus that we specified here. If you're familiar with Helm, and I hope you are, this saves you from executing a couple of commands like helm repo add, specifying a couple of arguments. Everything is defined in a file, and that part is awesome. And bear in mind, this is a simple example. You will see how this gets more and more useful as we scale up. If you would like to apply those releases, I mean, there is only one, but there could be more specified in a file. We would do something like Helmfile, and then we specify the path to the config file, which is helmfile-prometheus.yaml. Now, if you name your config file helmfile.yaml, then you don't need to specify the path, otherwise you do. And this is one of the things that annoy me with Helmfile. If we use global arguments, and --file is one of the global arguments, we need to specify all those global arguments before we hit apply or any actionable or any command, actually, really. So global arguments need to go before the command itself, which is pretty annoying, at least to me. Maybe I'm too picky. Anyways, we want to apply that and we want to wait. So let's hit it. Let's see what we'll get. You see, it is adding the repository Prometheus. It missed. It added the repositories. There is only one, but all the repositories specified to Helm, repo, local repo, list. And now it is showing us the diff. What will happen if we apply this? And it's a long list of the resources that will be created for us, simply because this is the first time we are executing this. Otherwise, it would show us the diff. So later on, when we start upgrading things, this will be extremely useful because it will show us the difference. It would be very similar to Terraform plan. And as a matter of fact, Helmfile apply command is a combination of Helmfile diff and Helmfile sync, right? So those two commands combined are actually the same as Helmfile apply. And right now, it just finished, right? It deployed whatever is defined in the Helm file that we are using. And in this case, that's only Prometheus. Now, let's say that we want to update our Prometheus installation. Let's say that we want to remove RBAC from Prometheus. I mean, you would never do that in real life, but for the sake of argument, let's say that we want to remove RBAC support for Prometheus that is currently running. And we could update our Helm file, but in this case, I have another one, a new one, to save you from updating files, and that this is the one, right? And the difference between what we had before and what we have now is that I set a couple of arguments. I'm setting RBAC create to false, so basically removing RBAC from this setup, no matter how silly it sounds. But I wanted to show you two things here. First, that we can set additional values through set or values instructions in the releases, right? So we can customize and say, hey, those are the values specific for this environment, those are the values specific for that. And set here is equivalent to --set. I mean, Helm install --set or Helm upgrade --set command. We could use values as well. Now let's see what we would get if we run this. And the command will be slightly different because I want to introduce you to a few additional options. And one additional argument is interactive. right? So we want to make this interactive. You will see what that means. We want to apply a new file, which is Helmfile Prometheus RBAC YAML, and we want to apply just as before and wait until it is finished. Pay attention that I'm specifying here now -- interactive. It will do some magic. You will like it. So it is adding the repository just as before, and now it calculated the differences. So if we apply this, this is what would happen, right? Some resources in this specific case would be removed, at least those resources related to RBAC, right? So we can see what will happen before it happens, what will be applied or removed or destroyed or updated in our cluster, and then we can make intelligent decision and say, hey, do I want to do this or not? And in this case, let's say that we want to do this, and we would type UI, and then we proceed, and Helmfile will apply the differences. I mean, Helm will apply the differences, but Helmfile allows us to inspect those differences. One of my favorite use cases for this are pull requests. We could execute Helmfile diff, which would show us the same differences without applying, without asking us anything. We would get additional information that would allow us to decide whether to merge pull request or not to the main branch, and then hopefully do the CI/CD pipeline or whatever we're doing to bring it all the way to production. So this provides this diff or interactive mode, depending on which command you're running, allows us to see what will happen before it happens. It is almost the same as Terraform plan, right? And that is extremely useful. It allows us to make educated decision whether we should move forward or not, or whether we should merge a pull request, or whatever the place is where you use this. Now let's see how we can destroy stuff. And the command is Helmfile, and we want to be interactive as well. Let's say we want to be asked whether we want to do that or not. And the file is Helmfile Prometheus RBAC, and we want to destroy stuff. Destroy. Since this is interactive, nothing got destroyed yet. The system is asking us whether we want to do that, and we are getting information. Hey, these are the releases that will be affected by destruction, that will be destroyed. Do you want to proceed? Yes or no? And I will say yes, and then it will destroy all the resources created from the releases specified in that Helm file. Now let's expand our horizons and see how we could maybe define multiple releases altogether. Let's say maybe define a whole environment and everything running there. One example file could be this one, Helmfile multi-YAML, right? And this one is slightly bigger, slightly more complicated, but still not a big deal. The first entry in the releases is the same as before. This is Prometheus repository and the release. And then we have two additional applications in this imaginary environment. We have DevOps Toolkit and DevOps Paradox. Now, DevOps Toolkit is using a local chart, unlike Prometheus, and the same thing is with DevOps Paradox. Both of them will be running in the production namespace, and then we have a couple of values that we want to overwrite for production. Specifically, this will be the tag that we want to use, and this will be the ingress host, DevOps Toolkit something. And this is yet another advantage of Helmfile. We can use environment variables. So in this specific case, the ingress host of DevOps Toolkit is DevOps Toolkit dot, and then the value of environment variable base host. And this variable is required, so we will get an error if you don't specify it. Further on, we have ingress host for the DevOps Paradox, yet another application, and this one is a slightly different syntax. It says, hey, use environment variable DevOps Paradox host, but if that variable is not available, if nobody specified it, the default value will be devopsparadox.acme.com. So we have default value, and then we can overwrite that value with an environment variable. Now let's see what happens if we want to apply this. So Helmfile and then -- file, Helmfile multi, and we want to apply and we want to wait, just as before. And we get an error, because if you paid attention, you saw that the base host environment variable is required. It is required env. That means that we cannot apply this without specifying that environment variable. So I'm going to export it as base host, and let's see localhost in my case because I'm running K3D. In your case, the base host should be something else if you're not running a local cluster. Anyway, specify whatever makes sense for your cluster, and then if we execute a similar command, let's say helmfile --file helmfile multi, and let's make it interactive. Why not? And apply --wait, and we will get first the diff. What will happen if we execute it? It takes a bit of time until it calculates everything, and this is the information of all the resources that will be created, updated, or deleted. I'm going to skip through that now and just say yes. Why? And then it will take a few moments until all those charts, all those releases are applied. So this is already a hint of how that works when running at scale, right? I have only 3 releases, but you could have 10, 100, 1,000. You could manage whole production from one single place. Okay, it took maybe half a minute. I mean, this depends on Helm, really. But anyways, now it's finished. We have here the summary of what happened. We got 3 releases. 3 releases were updated. DevOps, Paradox, Toolkit, Prometheus, those are the charts, those are the versions, and we can live happily ever after. Now, to confirm that our environment variables were really working correctly, I'm going to do kubectl namespace actually production, and then get ingresses. Right, and you can see here that the value of the ingress host of DevOps Toolkit is now DevOps Toolkit because that was hard-coded, and localhost was taken from the environment variable that I specified earlier. On the other hand, the DevOps Paradox host is using the default value, since we did not specify the environment variable and there was in the config file the default value. It is using that default value. Just to be on a safe side, let me open this in a browser and confirm that it really works. Let's see, localhost DevOps Toolkit.localhost, and here's my application. It is running. It is one of the 3 releases that were deployed through this config file. We got Prometheus, application 1, application 2, and we could have 1,000 if you want to. Let's take another look at the same file that we used before, helmfile-multi. We can see that there is room for improvement here. For example, namespace production is repeated for both of those, right? That's really repetition of the same thing over and over again. And we can see that the chart in both cases is the same as the name of the release. So we can reduce repetition probably, hopefully, somehow by creating some form of default values. So let's see how we could do that, how we can reduce repetition. I will do that with only those 2 values, namespace and chart, but potentially we can do that for many other things. This is the reviewed Helm file that has less repetition, or maybe not less repetition because this is a very small sample, but you need to imagine how this would help with the bigger sample. And we have a new instruction here that says templates. Hey, there is a template. It will be the default template. It will be called default, and it will have namespace set to production and the chart set to whatever is the name of the release. Right, so remember those 2. You will see soon why that matters. And missing file handler born doesn't matter. We'll skip it for now. Now, if we go back to the definition of the 2 releases, the Toolkit and Paradox, we can see this new thing. This is horrible syntax. I hate it. But anyways, what this means is inject the template called default. So whatever is defined in that default template over here will be injected into those releases. In this case, namespace and chart. So we can avoid repetition by creating templates and then injecting them into releases, which saves us from repeating ourselves over and over again. There is one more difference here. I'm introducing a new tag. So this definition, compared to the previous one, uses templates which should produce exactly the same results, and then we are updating the tag. I want to show you two things at the same time, right? So templating should not produce any difference because it's using the same value, the default template, and we should only experience the upgrade of the tag. So let's see whether that's really true. We'll execute Helmfile, and then we want to make it interactive to see what's going to happen, and apply and wait. Now it takes a few moments until it collects all the information. Let's see, and there we are. First of all, we can see that only the image tag is changing, right? So before it was 2910, now it's 2918. So we can see what will change if we apply this definition, this new definition. And we can also see that templating did not produce any differences. It just saved us from writing repeated lines of YAML. So we'll say yes, and then it will take a few moments until the application DevOps Toolkit in this case is upgraded. We could do many other things. We can, for example, define environments in Helmfile as well, and then define different values depending on the environment where that something should be running. So we could have a staging environment, production environment, integration environment, and then which releases should go where, what would be the specific values or the set values for those environments, and so on and so forth. We could split our definitions into multiple Helm files and then store them all in a directory called helmfile.d. We could create hooks, we could create layering, we could define secrets, and so on and so forth. The amount of things that Helmfile does is massive. It is a collection of different open source projects related to Helm and tying it all together, adding additional functionalities. It is massive. Now, whether you want something that massive or no, that's something that we might want to discuss a bit later. For now, let me destroy everything we did with a simple command, helmfile destroy, and there it goes. Everything we did is gone with a single command, because just as we can apply many releases at once, we can destroy many releases at once as well. There are many pros to Helm. There are many amazing things it does. We explored only a fraction of what it can do. So let's start with pros. What are some of the advantages of using Helmfile? To begin with, its ability to group releases. It is the ability to define all the releases for one or for many different environments, all in one place, store it in Git, and treat it all as a single unit. That's absolutely amazing. We always needed something like that. Simply dealing with dozens or hundreds of separate Helm charts and executing random commands in CI/CD pipelines was never a good option. This allows us to define what an environment or a cluster or a whole environment is, and it's absolutely amazing. It allows us also to define complex scenarios. We can remove duplication, we can define environment variables, we can define default values, we can create permutations of the things. My head hurts when I'm trying to think of all the different things and combinations we can do with Helmfile. There are secrets, hooks, layering. Layering. We can layer one Helmfile on top of the other one. Simply, the amount of pros is huge. I mean, not necessarily pros. The amount of things or the features of Helmfile is really impressive. But the biggest one, my favorite, absolute favorite, is diff. Being able to create pull request and then execute some pipeline that will create a diff of what it is right now running in an environment, and what would happen if we apply changes to a Helm chart or to a Helm file. That's gold. That's absolutely amazing. That's one of my favorite features of Terraform, and now we have it for Helm in form of Helmfile, and I absolutely love it. Now, there are disadvantages as well. There are cons to using Helmfile. To begin with, documentation is, how to put it, not very good. I will not say horrible, but it's really not very detailed. I like examples. And Helmfile doesn't have enough examples. Later on, once I'm comfortable with a project and going through a project using examples, some quick starts, what's or not, then I can go into detailed documentation, which also, by the way, is not very detailed for Helmfile. Another disadvantage, or at least personal disadvantage or dislike, is that I feel that Helmfile might be going too far with YAML, right? It is allowing us to do many different things with YAML, but if I get to the level that I want that templating and environments and required environment variables and this and that, if I get to the point that I need all those things, which is questionable, we might not need all those, but if I do, then I might be more comfortable than switching to some general purpose programming language. Maybe this is going too far with YAML. Maybe it would be better to use Go or JavaScript or Python or whatever is the language you want if you need all the things that they packed in on top of YAML essentially. So it might be going a bit too far with YAML, but it really depends on which features you use and which features you don't use. Anyways, Helmfile is very helpful in organizing releases, environments, clusters, organizing the stuff that is floating around in many different charts and in value files and what's not. But here comes the thing. Helmfile goals are in a way similar to the goals of GitOps tools, or the tools that we call GitOps tools today, like Argo CD and Flux. It has similar goals. I mean, not all of them, there are definitely differences, but from one point of view, we can say that both Helmfile on one hand and Argo CD and Flux on the other help us organize what is running where and store that information in Git. So from that perspective, Helmfile on one hand and Flux and Argo CD and whatever else we use and call GitOps tools today might be similar, at least in the objectives. So Helmfile is very helpful when we run things locally. You know, when you execute command, it's so much easier to do Helmfile this, then Helm this, Helm that, and combine many different Helm commands. For manual execution, Helmfile is awesome. It is also useful as a tool to inject into CI/CD pipelines or pipelines in general, but only if we want pipelines to do the deployment themselves. If we don't want that, and I suspect that we don't because we are moving fast towards GitOps world where we want to make changes to a Git repository, which you can definitely do with Helmfile, but then use some agent that will pull those changes instead of us pushing those changes through pipelines. If that's where we are going, and I believe we are, then Helmfile might feel a bit antiquated. What I'm really trying to say is that Helmfile is amazing, it's great, and you should adopt it right now if you're running at scale and if you're using Helm directly. However, if you're adopting GitOps tools like Argo CD and Flux, then I think that they are overlapping in many of the things, and Helmfile might be only a complication on top of those tools. Generally speaking, I prefer doing the deployments and defining things, defining environments and releases and what's not in Flux or Argo CD format. Combining one with the other might be too much, and I don't see the real benefit. So to summarize, if you're using Helm directly, manually from a terminal or through pipelines, and you want to continue doing that, switch to Helmfile. Helmfile improves Helm drastically. But if you want a way to organize your releases, maybe, just maybe, you should abandon the idea to push your changes to your cluster, from pipelines, Helm apply, Helm upgrade, or what's not, and switch into GitOps model where you have an agent in your cluster pulling manifests. And also, I personally prefer organizing releases in Argo CD way or Flux way than Helmfile. So use Helmfile if you're not ready to jump into GitOps. And I'm not really 100% sure that you should be using it if you're adopting Argo CD or Flux. But I might be wrong, and if I'm wrong, please let me know in the comments. And you know what to do next. Subscribe, hit the like button, do all the things. See you next time. Cheers.